Okay, boys and girls, welcome to video lesson 10-2 as we continue our exploration of circles. You're going to learn to love, understand, know, and admire circles. Circles, 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 circles. All right. Okay, a couple words you need to know. Again, just quick review. Arc. Arc length is a piece of the circumference of the circle. So this would be arc AB right here. That would be arc AB. It's actually a minor arc. We'll talk about that in a minute. We would write this as arc AB with a little arc symbol above. The central angle, a central angle is any angle that's where this vertex is the center of the circle. So this central angle right there, angle AEB, is the central angle that corresponds to arc AB. Okay, just know, we'll skip right down here, the measure of an arc right now. The measure of an arc, it's degree length, not the length of the arc, but the measure of the arc. The measure of the arc, so measure of an arc is equal to the measure of the central angle that corresponds to that arc. So the measure of arc AB is going to equal the measure of this central angle right here. A major arc is an arc that is greater than 180 degrees. So a major arc is greater than 180 degrees. So there are actually two arcs, AB. There is the minor arc that we have done in purple right here. So this is a minor arc, AB. It's less than 180. And we have a major arc, AB, which would be the other piece of our arc, or our other piece of our circle. So it's an arc that's bigger than 180. So again, I just define for you a minor arc. A minor arc is less than 180 degrees. And of course, a semicircle has a measure that's equal to 180 degrees. It's half of a circle. Okay, so, and sometimes the best way to do it to avoid the ambiguity is we label arcs with 3 points. So if I want to talk about this arc right here from A to C, this minor arc, it is a minor arc because it's less than 180. So this arc right here would be, and I'm going to highlight that in blue. So the minor arc, ADC, would be arc ADC, like that. So that would be the minor arc, ADC. And the major arc, if I talk about the major arc right here from A to C, would be around here like this. That's a major arc, right? So the major arc right here from A to C would be this red, and it could be written as arc ABC. So it includes an inside point, so I know which way I am going. If we see an arc that's labeled with just 2 points, like arc AB right here, we will assume we mean the minor arc. We will assume if I label an arc with just 2 points and there's a major arc and a minor arc, let's assume that it is the minor arc. Okay? And lastly, of course, we have a semicircle. The semicircle, BC, would be this arc right here. Unless I put in a third point, I would not know. If I just wrote arc BC, I would not know which arc I'm talking about, because arc BC could also be this arc right here. Okay? But if I wrote for a semicircle arc BDC, that would imply that I am BDC. That would be this arc right here. Okay, we're going to talk about our first theorem in chapter 10. Okay, if I know that angle A is congruent to angle B, those are both central angles. Now I also know that the corresponding arc, so arc MN, would be congruent to arc NP because they have the same measure as the central angles. And also, I also know that the chords MN, would be congruent to NP as well. So MN would be congruent to NP. So if angle A is congruent to angle B, then I have equal arcs, and I have equal chords. So if angle A is congruent to B, then arc MN is congruent to arc NP, and chord MN is congruent to chord NP. And actually, this theorem works in all ways. We can go and reverse the converse of each of these theorems. So if one of these are equal, in other words, if I know that my arcs, if I know my arcs are equal, then I know my central angles are equal, and I know my chords are equal. If I know my chords are equal, then I'm also going to know the arcs are congruent and the central angles. So given a pair of any congruent corresponding chords, central angles, or arcs, then the other chords, central angles, or arcs are also congruent. So let's try one here. In circle R, Kn is a diameter. Okay, so we have a diameter right here. I know that this central angle here at ORN is 42. Therefore, the measure of arc ON is 42. So that's 42 degrees because this piece right here would be 42. Okay, I know that the measure of arc N, or angle NRT, that's this angle right here, must be 89 degrees, because it would correspond to the measure of its arc. Measure of arc OT, that would be this guy right here in red. Okay, it's going to be 42 plus 89, which I believe is 131. Whoop. Okay, measure of arc OTK. OTK would be this arc right here. It'd be a major arc in blue. I'm sorry. Let me go back. Measure of arc OTK in blue would be this guy. Okay. Well, we do know that this arc right here, from N to K, is 180. Right, and I'm going to add the arc length, the arc measure of 42. So now I know that measure of arc OTK is 180 plus 42, which equals 222. And lastly, measure of arc NTK. NTK is this arc right here. I actually need another color, but let's go. It's this arc right here, NTK. That's a semicircle. So NTK is 180 degrees. Okay, let's try this one right here. In circle M, WS is a diameter. So this right here is a diameter. Okay, and measure of angle WMR. So that's WMR. That's this guy right here. This angle is congruent to KMS, which is this guy, which now means that this arc length must also be 56 from our theorem. Okay, find the measure of arc RS. That would be this guy. Well, I do know that this total length is 180. And I can subtract the 56 right here. So 180 minus 56 is going to be, don't tell me, whipping out my blue calc, just kidding, 124 degrees. Let's try one more here. Find the arc length of XY if measure of angle 2 is equal to 130. Okay, we're going to use our formula from last section. I know that arc length is equal to the central angle over 360 times the diameter of the circle, the circumference of the circle, which of course is 2 pi r. Okay, I know that my central angle is 130, or the arc measure is 130. So arc length is equal to 130 over 360 times 2 times pi times my radius, which is 2. Let's do some canceling. I'm going to cancel my zeros. I'm going to cancel my 2 with 36 and get 18. I'll cancel the other 2 with 18 and get 9. It looks like I have an answer of 13 pi. I got the 13 and the pi over what's left over, 9. There's my answer. And guess what, boys, girls, ladies, gentlemen, and Fred? That's it. That's all she wrote. We'll see you soon.